So what do we mean by frame of reference? It's about defining where do we and how do we measure something. Okay, do we measure a property at fixed locations, or do we measure properties in a moving coordinate system? Yes, and the measurements at fixed coordinates, this is what we call the Eulerian frame of reference. We're stuck at fixed locations. We can use fixed control volumes, and here now we can determine how can a property change at fixed locations. The other frame of reference is the so-called Lagrangian frame of reference, and it's based on moving or translated coordinates. It's like moving with the flow and doing observations while you move around. Okay, and the most common framework is the Eulerian one. We use the Eulerian frame of reference. Okay, so let's get started with it. So while for simplicity, we use a Cartesian coordinate, which is shown here. You have an x direction, a y direction, z direction, and you can fill this Cartesian coordinate system with cubic control volume. Okay, so that's shown here in the few examples. You stack them all together. Okay, and then you can consider the distribution of a conservative concentration field represented by values of C. We call that field, or this property, in each control volume. So for each of these control volumes, we have a value of C. Okay, and then we ask the question, well, how can it change? Which are the processes that can change the value distribution C within all these control boxes? What are the processes? And then we find out eventually that there's only two processes that change the concentration, and these are advection and diffusion. And let's have a look how these processes look like.